Okay, great. Well, next up is SKF. SKF may be a name familiar to you. It's a Swedish-based company famous for producing bearings that can be found in all kinds of products around the world. But the company is evolving to focus on creating solutions that deliver what they refer to as reliable rotation for its customers. I love that phrase. SKF is undergoing a transformation in manufacturing to support product lifecycle management, leaving the boundaries of engineering, and expanding its role company-wide to enable initiatives like Industry 4.0 and big data. So please join me in welcoming to the stage the Director of Product Lifecycle Management at SKF, Mr. Nick Leeder. Nick? Thank you, Nick.
Hi, good afternoon. We're really thrilled to have the opportunity to speak today. We're going through some amazing changes here at SKF at the moment. We want to talk a little bit about those. SKF has a long history in reliable rotation. The organization has been in existence for nearly 110 years. And over that period of time, we've grown our revenues through sales presence in over 130 different countries. Today, we have dealers, 50,000 of those globally. So you only have to travel a mere 50 kilometers to buy an SKF solution. We are truly a global organization. I'd like to take a moment, though, just to specifically focus on our operations. We have a manufacturing footprint across 115 factories which are producing SKF solutions. And these are located in 29 different countries. Our global headcount is around about 45,000 people, with nearly 30,000 of those working within the operations of our business. We are truly a global manufacturer. Now, everybody in this room today will come into at least 150 bearings. They'll be in the cars, the trains, or the planes that you took here today. I've confirmed with Hubert. In the Goldhofer trucks that push back the plane at the airport, to the skateboards your children play with at home, to the very fans that are cooling the projectors you're watching right now. SKF solutions are everywhere. So the core to SKF, though, and our solutions is the bearing. So here is a very simplified slice of a bearing. At the top, you have the outer ring. Highlighted at the bottom is what we call the inner ring. The little circle in the middle is the rolling bit. Every bearing generally needs some sort of rolling piece, and typically a cage which holds those bits in together. We've not shown those there today. So let me explain the challenge. On the screen, you see these words, BEDA. Now, BEDA refers to bearing data. It was a system that we developed in the 1970s. And every bearing can be described in a number of ways with codes that refer to each of the geometric parameters. For example, the width of that inner ring, the inside or outside diameters. And all you really need to do is define an axis of rotation. And the whole bearing can be described in that way. BEDA codes are really ingrained, though, in our thinking. We've been using them since 70s. And we need to change. This is about rethinking. This is about the change and the cultural change that goes behind that. We need to start rethinking how we use that beta code differently. Not just in the context of 1.5 dimensions, but embedding and enriching our 3D information with those beta codes. You see, beta codes were great in the 1970s, but it's no longer enough to support what we need to drive Industry 4.0, or for the English-speaking, 4.0. We need to start rethinking about our products and our process information across the entire value chain. So in this diagram is a very simplified view of what we do. So let's start on the left-hand side. So I think it's over there. Left-hand side. We start to reuse this information to support our customers and our sales process. This information then is also digitized during the engineering processes and then passed on to other key systems that allow us to plan the manufacturing of our products. We then need to execute against this information. So that's all the way down to the shop floor. And when we're actually manufacturing it, we need to capture what we actually built. Finally, we need to be able to trace what we shipped to our customers to support ever-increasing regulatory needs and requirements. Now, the thing that glues this all together and binds this all together is the information. And we call this information the digital twin. So how did these information, or these changes, actually come about? Well, as I'm sure many of you know, that when you start defining factories, you tend to start with the manufacturing process and the machines. You focus on the machine performance as the primary driver to defining the factories. But we quickly realized that machine performance alone was not enough to deliver Industry 4.0. We had to somehow turn that light on in the factory. For Industry 4.0 to work, we had to ensure that we had the right information to drive the machines. We had to have the digital twin to support the factory. We had to connect that information down to the machines, and we had to collect the information to support the creation of the digital twin. So let's go back to the digital twin. Here she is. Today, we are building our world-class manufacturing capabilities on this blueprint. We're starting small, but we plan to scale fast around these implementations. In the last 18 months alone, we have announced investments totaling 500 million SEK in world-class manufacturing. And the first factories going live with a digital twin will go live next year. So to start with, we need to connect. We need to distribute that information of the digital twin to the people that need to use it. We need to integrate that information to the business systems and connect it down to the machines. We also need to increase the level of process automation to ensure that the information in the digital twin is created without additional effort within the organization. This cannot lead to additional burdens and work. So, enough about the theory and PowerPoint. Let's see the digital twin in action, shall we? That was actually one of the inner rings being machined 2 weeks ago in one of our factories in Germany. So you can see from the video that this is real today. But where will we go tomorrow? So this is actually the same shop floor you saw in the video a few moments ago. So let's put on our augmented safety goggles, and they have to be safety goggles if we're on the shop floor, and see the digital twin through different people's eyes. So you'll see here, we're just showing some level of augmented information available to an operator. We will increase the level of sensors on our machines, and this will allow us to provide more feedback to the operators on the shop floor working those machines, providing that information in real time about the performance of the process going on. Above that, you'll see some more information. Now, we can then start looking at the overall machine performance, the OEE information, and the maintenance status can also be shown. Now, if I'm a production engineer, it's not just the one machine I need to look at. I need to look at the entire shop floor. So as I walk down the shop floor, I can see each of the machine's status and the KPIs provided without having to go to each machine, checking paper, asking the operator how things are going. Also, we're connecting more and more data around the bearing and embedding that in the components themselves. Now, using that same technology, we're able to provide serial level specific information of the bearing itself. So, for example, if I'm a quality engineer, just by looking at the component, I will be able to see critical to quality information and performance about the components I'm looking at. Now that's wonderful. I'm sitting there on the shop floor with my goggles on, seeing all this information. But not everybody can be physically there on the shop floor. So that same information can be accessed remotely through many different devices in a secure way. This is where we are heading. Now, to achieve this tomorrow, we need to implement a 4-stage approach. The stages are connect, collect, correlate, and collaborate. So let's just go and spend a moment to go in a little bit of detail. Now, you've already seen in practice from the video and the previous slides where we have started with connect and collect. So now we add correlate. We need to use the vast amount of information collected to make our processes intelligent. We need to provide analysis of that performance, and in the same way start to predict so we know when to take action to ensure world-class quality. And with this new information, we can now collaborate. This intelligence will help us simulate both the product and manufacturing performance. And through this simulation and the information within the digital twin, we will be able to provide full product and manufacturing validation in a traceable and auditable way. So let's just take a moment to look at where we are today and where we'll be in the future again. We are starting small. So right now, we're really focusing on connecting the digital twin and its information down to the machine. In 2017, we'll start to collect ever-increasing amounts of information to start analyzing the performance. This is a radical change and step up in our capabilities. As more and more machines come online with the digital twin information, we will be able to correlate and predict using this information at a factory level. But the real power will be unleashed when we start collaborating. Not just in one factory, but across the entire value chain. So you've seen our vision and our strategy today. But I just ask one thing of you. One thing you remember and take away from this presentation. Please, can it be this formula? Does anybody know the simple equation? Okay, let's start then. NT. That is new technology. You've seen a lot of that in the presentation today. OO refers to old organization. This refers to legacy processes, ways of working, old ways of doing things. The problem is when you add new technology to your old ways of working, this just creates an expensive old organization, EOO. If we approach Industry 4.0 and the new digital age by just implementing new technology, we will not achieve the potential value it can deliver us. We need to remember that technology is only the enabler. We must rethink how we work at the same time. And if we can do that, then and only then will Industry 4.0 and the hype around the Internet of Things finally start to deliver its full potential. Thank you very much for listening today. Thank you.
Nick, thank you. Thank you
Thanks.
for that highly informative presentation. It's great to understand a little bit about what's going on at SKF and share your experiences with them, with those of us here in the audience. I would say it looks great on slides, but I'm sure that there's many of us in the audience today who are wondering just how difficult it becomes when you have to translate those slides into human behavior. Any thoughts or advice that you might share with the audience on how you've approached that?
Sure. I mean, the real thing is, as I said, it's not the technology, it's the changes you have to make in the organization. And the problem with digital is, particularly when you're talking with engineers or the guys in manufacturing, it means nothing until it becomes physical. So what we're doing is we are starting with very small examples and illustrations of how this stuff actually works. So we make the physical version of the digital, and then people start to get it. And when you show them, and when they start to understand, I think I was here just earlier on in the presentation before this, the floodgates are open. People want this. I've got diary dates in July 2017 for the first factories already. So it's quite a scary prospect.
That's great. That's great to hear. So thank you again for sharing your experiences with us. And just as a show of gratitude, a little gift for you from PTC and from PTC Forum. Again, join me please in welcoming, in thanking Nick Leeder for sharing his experiences with us here today. Nick, thank you very much.
Cheers.
Thank you again.
Cheers, Eric.
Okay, so that wraps up the content portion of PTC Forum Europe.